With my name, it's Cordelia Kataria, and I am a 9-year-old computing explorer and problem solver. And today we're going to be doing a computing live class, and we're going to repeat that over the next couple of months. And I hope that in the process we'll learn a lot more about computing and maths, logic, and problem solving, and that sort of stuff. So I've got this problem on the screen, and it's the USA Computing Olympiad, January 2023, problem 1. And so let's read out the problem. So Farmer John has N cows, where N is between 2 and 10 to the power of 5, and each cow has a breed that is either Guernsey or Holstein. As is often the case, the cows are standing in a line numbered 1 to N in this order. Over the course of today, each cow writes down a list of cows. Specifically, cow I's list contains a range of cows, starting with herself, cow I, up to and including cow E of I, where E of I is between I and N. FJ has recently discovered that each breed of cow has exactly one distinct leader. FJ does not know who the leaders are, but he knows that each leader must have a list that includes all the cows of their breed, or the other breed's leader, or both. Help FJ count the number of pairs of cows that could be leaders. It is guaranteed that there is at least one possible pair. Now the input format is the first line contains N, the second contains a string of length N, with the ith character determining the breed of the ith cow. So like, if the first cow was Guernsey and the second was Holstein, it would be GH. And the third line contains E1 to EN. So basically the list of cows. So the output format is output the number of possible pairs of leaders. So sample input is 4 GHHG 2434, and the output is 1. And because the only valid leader pair is 1, 2. So cow's 1 list contains the other breed's leader, and cow 2's list contains all cows of her breed. No other pairs are valid. For example, 2-4 is invalid since cow's 4 list does not contain the other breed's leader, and it also does not contain all cows of her breed. Another is 3 GGH 233, and the output is 2. There's 1 3 and 2 3. And the scoring is inputs 3 to 5, where N is less than or equals to 100, and 6 to 10 is less than or equals to 3000, and 11 to 17 there's no constraints, no additional constraints, like apart from 2 is less than or equals to N is less than 10 to the power of 5, and I is less than or equals to E to the power of I is less than N. So
can we try seeing how the first example is working?
So how it works is basically there's only 1 2, that's the only valid one because it'll be this one and this G and this H because like 2. This is all cows up to index 2, which is 0, 1 and 2. Wait, 1 and 2. And it includes the other leader and cow number 1, that's all the cows up to number 4, so all of that will be, and that includes all cows Holstein. So that's basically why 1, 2 works. And if you try it, all the others don't. So that's basically why the output is 1.
Right. Okay, so we have like 2 conditions in the third paragraph, I guess. Yeah. So either we need to cover all the cows of our breed, or we need another breed's leader, right?
Yeah. So
Cool. So we can just write these conditions down. Is my writing audible? Sorry, can you see my writing?
yeah, I can.
It's neat. Okay. So how are you thinking about solving this one?
So what I'm thinking is that we could try brute force and go through every single pair, but that wouldn't be very optimal because it has n cows, so 2 to power of 10 to power 5 is probably ginormous.
Why would it be 2 to the power 10 to the power 5?
Yeah.
It would be, I think, 10 to the power 5 into 2, right? Like squares. Yeah.
I think it would, yeah. So that'd be so that would be 10 to power of 10.
Yeah. Okay, but even in that solution, let's just try figuring out the brute force solution.
Yeah.
So, if we just check every pair, even then can we find out, or do we need some more computation?
If we take every pair, then I guess we can find out because we can count the total that actually worked.
Alright. Okay, so can we think about any optimization here then?
So I guess we can use the fact that no two cows can point to each other because the cow that's later in the line can only do cows after it, so we can use that fact. So that means that at least one of them needs to have gotten every single one of its breed.
Yeah, that's true. So do we have any sort of like candidates for like what cows will be the leaders?
Yes, we do, because the earliest, it says that it's guaranteed that there is at least one possible pair. So that means that our possible candidates are the earliest ones, because they could have gotten the most like of their breed.
Okay. So it would be like the first Guernsey cow and the first Holstein cow, right?
Yeah.
Hmm.
Let
That's
me
true.
write that down.
Yeah.
Sorry for the bad writing.
It's okay. Okay. So that is right, I think. But there are a few additional constraints or a few more conditions to look at. So it states that either it should have all the cows of our breed or have other breeds leaders. So now we need to look at those cases as well. Uh, so we have like the candidates at our hand, but we also need to check if those candidates are like possible solutions.
Yeah. So what we could find is which, if one of those, I guess we could find if one of those has all the cows of their breed, and if it doesn't, then, and if both don't, then that means that then I guess that means that either one is, that one of them is not a possible solution, or both.
Could you say that last line again?
So if both haven't gotten all the cows of their breed, then wait, I guess both do have all the cows of their breed, because actually they might not. So if both don't, then I guess that means that one of them cannot be a leader, or both.
Yeah, so it's given in the constraints that every like there is at least one possible pair. So at least there will be at least one leader in the answer.
Yeah. I
Well,
mean,
yeah, go ahead. You were saying something.
so I mean, either the earliest G is not a solution, or the earliest H.
Yeah. So if they are not the solution, then what is their condition to be a part of the solution?
Then I guess they have to get the other breeds a leader.
Right. Right. All right. So we have a somehow working solution. Uh, so you can start writing some pseudocode. So do you want to write that down?
Actually, I think I'll be writing in Python. Actually,
Okay, we just need to write a very high level code. So anything works.
Wait a second. Star. Yeah, that's a star. So basically what that operator does is it splits the GHHG into a list with characters like G, then H, then H, then G. Then
Which operator?
like the these, the brackets and the star.
Oh, okay.
So then we'll have that other list, call it array this time, is come on. Okay, so that's the array.
Okay.
Okay, so then
Okay.
so we'll have to find the earliest G and H. So right, early G. For binary of n, if wait, if
So maybe you can define early G and early H as -1, and once you
yeah, good
find
idea.
a G and H,
Yeah, that's probably better. If array of I, wait, no, not array L. If L of I, so if that is equals to wait, I think we'll also have to set a flag to 0. I mean 1.
so the early G and early H act as flags themselves. So you can add like something if Li equals G and early G is equal to -1, then we set early G. That
Oh yeah,
works,
yeah,
right?
yeah.
Mhm.
If L of I equals to a G and early G equals to -1, then think I'll have to zoom out even more. One, then 3. Then we will then just do the same for early age. So then we've got the 2 candidates defined.
Right. So we also need to see, like, for a cow to be a candidate, we also need to check if it can reach the last. Like if it's a G, we need to check if it can reach the last G, and if it's an H, we need to check if it can reach the last H.
Yeah. So what we can do is
we can make 2 more variables. Do this.
Yeah. So what we can do is actually, why do we need 2 more variables? Because I think we can do L of early G to array of, not early G, of like, for storing those 2, like, yeah. So now and G equals to array of early G.
Right.
And H equals to array of an early H.
So for finding early G and early H, we can actually shorten the code a lot. So there is an inbuilt function in Python where you can do something like l.index and then enter G.
Yeah.
It will give you the first G character. So instead of writing this part of code, we can just use that. But it's fine. I'll just write it in a comment here.
Okay.
So it's something like
I think I'll have to zoom out a lot more. I think I should add a new page after we're finished this.
Okay.
Oh, that didn't work. Okay. So then we can then what we can do is we can see if why is it green? Now if L of early G to end G Here is that. It's actually L of 0 to early G plus L of N G 2 minus 1
What are we exactly writing?
So I'm writing if wait. So what I'm writing is not. So what I'm writing is to check that there's no G outside the range of between early G2 and G.
So if you have like the first occurrence of the G and the last occurrence of the G, then all the G's will be within the subarray, right?
So yeah. So I'm checking if so basically checking if all the G's are actually in that subarray.
Okay.
So then actually that means that it's so then so now this code basically says, so it basically says that if there is a G inside, if there is not a G inside that range, then it will go inside the if thing. So then that means that the early H contains all the H's. So then what we do next one? So then
On this condition, so why are we checking if all the G's are between the first G and the last G?
I'm basically checking if all G's are from the early G2. So so I'm basically checking if the early G cow can basically
Be a leader, right?
Yeah.
So we only need to check if the if arrays, like if the array of that so I'll try writing down the condition there. So we need to check if array of let's say early G is greater than or equal to last end G. We can write something like this, right? That way we know if this G is a possible leader or not.
Yeah.
Your voice is breaking. This
I guess can you hear me now?
yeah, now I can hear you.
Yeah, so I guess we could do that. I think I've run out of space.
Run out of space hasn't. You can just keep scrolling down. Use two of your fingers to just go further down. H contains G, early G. I'll just write it as EG. And the second case is H contains all H.
It's being a bit slow.
It's being a bit
Slow.
oh, okay.
There we go.
Are you able to see it now?
Yeah.
Okay, so we have to write something to check these two conditions, right?
Yeah.
So for that, do you want me to write the code or do you want to try it yourself? Because
I think I want to
if we are able, okay, if you are able to write the code for this one, then the code for the second part, which is like checking if, like the second part would be if H is illegal.
I think
Right, so that code will be similar.
I think I want to take a bit of a break with writing the code. So,
Okay, sure.
Yeah, so you can do it.
Okay, so we can go for something like for I goes from 0 to n. Do you want me to write it in Python? I'll just write it in Python so that the code stays uniform. So for I in range n. So first we check if. So first I'm checking for this condition, right? The first condition.
1 second, I think something happened.
What happened?
I can't see Discord anymore. Wait a second.
Okay.
Where's Discord? There we go. That's better. I got it started now.
Okay. So I go from the range from 0 to n. So if the so now I have to check if the h comes before the g. So if I is less than eg, so we can actually just run it till eg only. We don't need to write this n eg. If I is so now we just need to check if the H contains all the G's. So if array I is array I is greater than or equal to EG, and also Li is an H. These two are the conditions, right?
Yeah.
So if this is the case, then we can do something like an answer plus plus, or like answer plus equals 1.
Yeah.
Does that make sense?
Yeah. Because that's counting the number of times.
Yeah. Counting the number of answers.
Yeah.
So this basically helps us get the answers if G is the leader, and the same code pattern will follow if H is the leader, right?
Yeah.
So basically do the same. If H is the leader. Does this make sense?
Yeah.
So do you think we're missing out on a case or we're overcounting something here?
I think we're overcounting the early G and early H, possibly.
Yeah, so you're exactly right. So if early G is a leader and early H is a leader, like let's say both of them are leaders, then we are overcounting case, right?
Yeah.
So you want to write down the conditions where they are the leaders, so we can just do a answer -1 at that place.
Okay.
You can try just like thinking about the condition. It's pretty like you can do it.
1 second. I need to get the screen thingy.
So this is what you basically need to do.
So the conditions are, so if so 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 if early G and early H are both leaders, then yeah. So then what we can do is check if early G is less than or equals to check whether early G contains all the if early G contains all the thingies. Check if early G contains early H
Right?
and also or if it contains all the G's, and
Right?
and we could also check if do the same for early H, and if both of them are leaders, then just -1.
Right. So if this is the case, we can just do it -1. So can we like formalize it in a if condition? In an if condition?
So then we could do 1 second. Oops. Can't do it. So what we can do is we can so if the if array of early G if that is more than or equals to, and more than or equals to, using a bit of math notation there, and G, then we and if that equals to NG with R array R if R R early G is less than early G is less than early H, EH,
Right.
less than or equals to array of early G.
Right.
So then, and then if that and just all of this the same for G early H, then
Yeah.
then answer minus equals 1.
Yeah. Exactly. And then in the end we can just like print answer.
Yeah, whoops.
Yeah. And I guess we've solved it, right?
Yeah. Where is OBS gone? There it is. Okay.
So are you like satisfied with the solution?
I think so. So should we do question 2 maybe? Okay. It's already been an hour. I think we can stop now.
Yeah. It's like 11:30 right now.
Okay, so my mouse gone.